hopefully you will find this fairly easy and you'll be like, oh, I wish it could be like this every day. Okay? Our learning goal today is being able to add and subtract monomials. And then we're only going to work with, if it's more than a monomial, then we're only going to work with addition today, and tomorrow we'll move into subtraction of polynomials, okay? So when we are adding and subtracting monomials, TJ, would you have a seat? When we are adding and subtracting monomials, we're going to follow these steps. We're going to identify the like terms. We're going to rearrange, putting the like terms beside each other in the expression, in the polynomial, and then we will combine like terms so that we have a simplified polynomial, basically. That's kind of what adding and subtracting monomials does, is it simplifies the polynomial. You practice that today to be able to name polynomials. So we have 2x squared plus 3x squared plus x. How many monomial terms are there? 3. Currently there are 3. Can we make it so that it has fewer terms? Yes, because which are the like terms in this one?
X squared.
The x squared. So see, now you guys know that the x squareds are like terms. That was just like nothing for you, right? And they're like terms because why?
They're the same variable exponents.
Yeah, the same variable raised to the same power. So you're going to think of, when there's more than one variable involved, you have to think of it the same way. It has to be the same variables raised to the same powers. They have to match exactly. So in this one, the x squared and the 3x squared are already beside each other. So let's just box those and say, you know what, that's kind of our way of showing their like terms. What happens when you add x squared? What do you get when you add x squared?
X squared.
They stay x squared, don't they? We're not multiplying, we're adding. So we have x squared still, but how many of them do we have? We have 5 of them. So we have 5x squared. We bring down the plus x. It doesn't have anything to be added to unless we can add it to that 5x squared now.
No.
Okay, it doesn't have an exponent of 2, so we have to leave it as it is. So we are going to say that it's as good as it's going to get, 5x squared plus x. You know, while we're doing these, we're just going to practice classifying them. What degree is this polynomial?
2.
2. When you have a polynomial in one variable, we can give it a special name maybe. What is a degree 2 polynomial? Uh-oh. Stumped you. Degree 2. You might want to open your SQ3Rs. I'm not going to let you open your book because you were supposed to do this in your SQ3Rs. And if it isn't in your SQ3R, you're going to want to get it in there because you're showing me you don't have it memorized. It's quadratic because it's a degree 2. Okay, how many terms does it have?
2.
2. And if it has 2 terms, it is binomial. So you know what? Just for the fun of it, let's just get that name. Let's call that so we get used to doing this. This is a quadratic binomial is what we end up with. And we start learning how to spell those words and maybe say those words. Okay, questions anyone? Okay, the next one is polynomial in one variable. So that means, oh, I gotta backtrack. The last one was in one variable. So when we give our final answer, we should also give it in standard form. Is our last polynomial answer in standard form?
Yes.
Yeah.
Because?
It goes from
Least to greater.
Yeah, the degree of the first term is 2, the degree of the second term is 1, 2 is greater than 1, it's in good order, isn't it? It's in what we call in standard form. Okay, the next one is in one variable also. So when I am rearranging these, I like to just start putting them in the groups of, like kind of getting into standard form almost right away, okay? So I'm going to first of all change this to add the opposite, that subtraction, because sometimes students think, well, when you rearrange the subtraction, it just stays where it's at, and you just flip the terms. Well, which terms are like terms in this polynomial?
4 to the
4 to the
4.
Okay. Not Z4, not Z4.
Z
Z
raised to the fourth power.
Thank you very much. Okay, so 4z to the fourth plus 16z to the fourth, those are like terms. So we'll group them together. Plus, do we have any other like terms?
Negative
The negative 8 and the 2. Okay, so we have negative 8 plus 2. There's another group of like terms. And have we accounted for all of the terms that were originally in it? Okay, what's our 4z to the fourth plus 16z to the fourth? 20z to the fourth. Now, I am going to keep stressing this, that when we add, they stay when they were. It's just the number of them changes. When we start multiplying, something else is going to happen. We have to keep it straight. When we're adding z to the fourth, stay z to the fourth. How about negative 8 plus 2? What's that? Negative 6. So plus a negative 6. Cleaned up, it would be 20z to the fourth minus 6. And before I circle it, I'm going to decide if we have it in standard form. Oh, here's a little hint. There's only two terms, two monomial terms. And one of them is a constant. If the constant's at the end, it's in standard form. So this has a constant of that, basically really a negative 6, and it's at the end. So you know what? I don't think there's anything we could do. Oh, now you tell me, what kind of a polynomial do we have here? Devin says a quartic binomial. You guys agree with it?
No.
Why is it quartic, Devin?
To the fourth degree.
Okay, it's degree 4. It's a degree 4 polynomial. And there's two terms, so that makes it a quartic binomial. Let's write that. Quartic, which is different than quadratic. So make sure you can spell properly and get the right word down. So I don't have to take points away in an assessment because I can't tell if you mean quadratic or quartic. Okay, our next one. Tell me something about our next one that's different than these other two that we've done.
They're all like terms.
They're all like terms?
No.
Well,
All four monomials are
two
like terms?
x to no.
Like there's two groups of like terms.
Two groups of like terms? Well, there were two
With
groups
two
of like terms in the last one.
But they're two variables. There's two
Oh,
variables.
there's two different variables. Two different variables. So when there's two different variables, what can't we say? You can't put it in what?
Standard form.
Standard form. When there's more than one variable, you can't necessarily talk about standard form, but then you kind of talk about, you try a little bit to use algebra etiquette. What does algebra like with these darn letters?
No.
Put them in alphabetical order. So who gets to be first in the alphabet? X does. So let's first of all change this to add the opposite. So we have plus a negative, well, I don't know, you can stick a 1 in there, plus a negative 1 again. I'm going to just, So you said that we have two groups. So the x to the third powers are like terms. And x, you said, comes before y in the alphabet. So I'm going to let these guys come together at the beginning. And I'm going to let the other guys be the other group at the end. They get to make their group. So what do we have here? What do the x cubes become? There's only one of them, right? 2 plus negative 1 is 1. And 1 x cubed, well, I'll just do it and I'll clean it up later. How about 7y cubed plus negative 1y cubed? 6y cubed. So, good order, according to algebra etiquette. Yeah, we got the x's first, so we'll just clean this up and say we have x cubed plus 6y cubed. There's our sum. Because we changed it to add the opposite, so we get to say it's a sum now. Okay, when it is more than one variable, we don't talk about degree, special degree names. We could say this is a degree what polynomial. 3. It's a degree 3 polynomial, but we would not call it cubic because there's more than one variable involved, okay? Okay, let's look at number 4. Go ahead, you do number 4. What's true on this one? All 3 monomial terms are like terms. Their variable parts match exactly, don't they? Okay, so then what do?
Just add them.
Just add them. 9 plus 5 is? 14. 14 plus a negative 13 is? 1. So we end up with 1 m to the 3rd n to the 2nd. Is that how we see it in an answer bank?
No,
No, they would do what?
they would want.
They'd take away the 1. They'd clean it up to be m cubed n squared. M to the 3rd power, n to the 2nd power. What do we call it when there's only one term? Monomial. This is a monomial. What's the degree of this monomial? It's a degree 5 monomial, isn't it? 3 plus 2 is 5. Okay, questions? So notice, every one of these we were adding monomials. There were no parentheses or anything. The first one we had 3 monomial terms we were adding. The second one we had 4 monomial terms we were adding. The third one we had 4. The last one we had 3 again. So we are just adding monomial terms on this side. Okay, let's go to the back side. And let's talk about when they're not just monomials, what do? Well, when we have parentheses in problems, addition problems, typically that means they're trying to show you that there's something special about this. In this case, the parentheses are showing that the polynomials are being added. We have a polynomial being added to another polynomial. Tell me something about the first polynomial in number 5. What kind of polynomial is 4m squared plus 5? What classification can we give 4m squared plus 5? Quadratic, because it's degree 2. Binomial. Okay, it's a quadratic binomial. Okay, how about the other polynomial, m squared minus m plus 6? Quadratic again, because it's still degree 2, but now it's a trinomial. Now, there's no rule that says, you remember when you were doing matrices? Remember when you were adding matrices? What had to be true?
They have the same
Dimensions, there you go. They had to have the same dimensions. When we're adding polynomials, they don't have to have the same number of terms. We get to just, because it's addition, we can just drop those parentheses. So we're just going to ditch the parentheses. And I'm going to change my subtraction in that second polynomial to add the opposite while I'm at it. And because the first one had 2 monomial terms and the second one had 3 monomial terms, altogether we should have 5 monomial terms in this addition problem. And now we're going to rearrange to put like term groups together. What should be first? Because there's only one variable involved in this one, so we should be able to do standard form. Where should we start? With the m squares, okay? So we have 4m squared plus that 1m squared that's there. I can stick a 1 in there. Plus, don't lose your addition signs. What would be next in standard form?
the 5 and 6.
The 5 and the 6? What did I say? What should be at the end always?
The constant.
The constant should be at the end. So if you're saying the constant's next, there's nothing else left. AJ?
It'd be the -1m.
It'd be the -1m. Does anything get to be added to that -1m? Does it get to group with anything? No? Okay. Now plus 5 plus 6, and they are a group, aren't they?
It's actually 5 and then 6 and
Doesn't matter, 6 can come first. Addition allows that. So we have, how many m squareds, class?
Five.
5. How many m's, class? 1. How can we clean that up? Just minus m, yeah, minus m. Back the way it was kind of up at the beginning, right? And then plus what? 11. Standard form, degree 2, degree 1, degree 0. It's in descending order. We cleaned it up. What do we have for an answer? What kind of a polynomial? Quadratic trinomial. Get in the habit of naming these to yourself so that you can learn those, okay? Okay, you guys try the next one. Go ahead and do it. Austin, what did you get for a final answer?
12a is cubed plus 15a squared minus 16a.
Anybody want to agree with Austin? Devin does. Oh, lots of people do. Okay. Anybody want to change our mind? Anybody want to change the majority's mind? Now, did you notice what I did after I dropped the parentheses and changed it to add the opposite? What else did I do? Look at that red line. What else did I do? And when do you think I was doing that?
You cross out the ones that were like terms when you wrote it down.
Yeah, as I was going along, because it's really easy, especially when polynomials have a lot of monomial terms, it's really easy to leave one or maybe even a couple of them out, and then your answer is wrong because of that. So I count up and I mark off or count up and say if I had 1, 2, 3, 4, 5, 6 at the beginning, I better have 6 when I'm making my groups, right? And then I can combine and say, you know what, is this in standard form? Did I get it in standard form?
Yes.
Did you get it in standard form? Okay. Now tell me what kind of a polynomial we have.
Cubic triangle.
Quadratic triangle.
Wait.
Wait, no.
Well,
No, it's
Oh,
degree.
it's triangle.
It's degree 3, so that makes it cubic, and there's 3 terms, so that makes it a trinomial. Okay, good. Okay, let's just quickly do these last 2 here when we have these xy's and these x's and these y's and these whatever. Okay, so first thing is, because it's an addition of polynomials, I can just ditch the parentheses. And then now I'm going to decide what are like terms. Do you have any?
Wait, yes we do.
Yeah, we do.
Negative 3xy
10xy.
and 10x.
Oh, the xy terms are like terms. Okay, so I'll let those guys come up here to the front. Because are we going to be able to talk about standard form this time? Why not?
Because they're all. Variable.
Because there's more than one variable. Okay. And then are there any other groups of like terms?
No.
No. We have an x left. So I've used these guys up. I have an x left, I have a y left. So I say, you know what? Then I'm going to have plus x plus y. So how many xy's are there?
No.
10 plus negative 3.
There's 2 sets.
Well, these are xy's. These are xy's. These are x's. These are y's. These are xy's. Is 7. Okay, and then can x and y, did we just say? Yeah, because we didn't make them into groups, did we? Okay. Well, since we can't talk about standard form, but what if you're taking a multiple choice test, this one shows up on your math test, and this is your answer on your paper you worked out, but yet that's not one of the choices that they gave. But they gave this choice.
It's the same thing.
Just different.
Just different order, yeah, we get to do that in addition, don't we? Just different order, okay. Okay, and the last one. Take a look at this one and see what do we end up with. Again, this is the part that lets us drop the parentheses. This right here, this is important, people, pay attention. This is important. This plus sign between the two polynomials says, you know what, those parentheses are worthless. You can ignore them, but don't ignore that plus sign, don't ditch that between them.
So if it's subtraction, then you should still do the
Yeah, then we're gonna talk about that tomorrow. What are we gonna do if it's subtraction, okay? So now, oops, I left out something in this 14 and 3/10. I left out the x squared part. Don't wanna do that. I wanna make sure I copy it right. Okay, do we have any groups of like terms?
Yes.
Which ones?
The x squared,
The x squares, and should they be first?
yes.
Yeah, they should come first. So they become a group. And even if you don't like this boxing thing, I tell you, it's worth doing just to make sure that you account for everything properly. Do we have any other groups of like terms?
The negative one.
The -4 and the 1, those are constants, okay? Would they come next in standard form? No. What would come next in standard form that's left? Yeah, we have this 5x left here. Does it have are there any other x terms?
No.
No, so we're not gonna be able to group that with anything, but then you said we could group -4 and 1 together. Okay, how many x squares do we have, class?
16.9.
16 and 9/10, 16.9 x squared plus
5x.
5x plus
Negative.
-3. Oh, I gotta clean that up now. 16.9 x squared plus 5x minus 3. And it's in standard form, right? And we have a quadratic trinomial. Yeah, that's what we have. Okay. Questions? So, this is pretty easy, right? It's just combining like terms. That's all we're doing, aren't we? Okay. Okay, I'm gonna get your worksheet out to you. If you are one who has some math testing to do, you might want to just use a few minutes, or you can come after school tonight or before school tomorrow morning, but our goal is really to get this done this week. We don't want to be dragging it into next week. So